All right, let's get right into it. Today we're tackling a massive question, one that could totally change how we think about healthcare. Is an AI really ready to be your doctor?
I mean, you've seen the headlines, right? AI is acing medical exams, and tech companies are pushing these tools for doctors to use. But how much of that is just hype? Can you, and maybe more importantly, should you, actually trust an AI with something as precious as your health?
Well, we're not going to just speculate here. We're going straight to the source, to the hard evidence. A brand new study just put the most advanced AIs on the planet through a completely new kind of medical exam. And honestly, the findings are a huge reality check. So let's dig in.
Okay, so to really get why this new study is such a big deal, we first have to understand the core problem with how we've been testing medical AI up until now. There's this massive gap between the promise of some AI superdoctor and the actual nitty-gritty reality of checking if these things work.
For a long time, the main way we'd grade an AI was to have it take a test, like the U.S. medical licensing exam. But here's the thing, and researchers have been saying this for a while. That's a multiple-choice test. It's great for seeing if you've memorized facts, but that's not what a doctor does. Real medicine is messy. It's uncertain. It's a step-by-step process of figuring things out.
So, a team of brilliant researchers decided, you know what, we need to build a better test. They wanted one that doesn't just look for the right answer at the end, but actually sees if the AI can think like a real doctor.
And here it is. This is our source material for this whole explainer. It's a 2026 study that was just published in a super respected journal, JAMA Network Open. A team led by Arya created a whole new way to measure if an AI really has clinical skill.
They call their new metric the Prime LLM score. And what's so cool about it is that unlike a simple accuracy test, it doesn't just care if you get the final answer. It measures how well the AI performs across the entire process. The key here is that an AI has to be good at every single step to get a high score. It's designed to catch an AI that's just getting lucky.
So here are the 5 stages it tests. Think of it like a detective story, right? First, a doctor comes up with a list of possible suspects. That's called the differential diagnosis. Then, they order tests to gather clues. After that, they name the final culprit, decide what to do about it, and then answer any follow-up questions. A good doctor has to nail all 5. The big question is, can an AI?
Okay, so the researchers took the best AI models out there and put them through this new test. So, how'd they do? Well, let's take a look at their report card. And spoiler alert, it is pretty shocking.
And believe me, this was no small test. They took 21 of the latest and greatest AI models. We're talking the big ones you hear about, like GPT-5, Claude 4.5, Gemini 3.0. They ran them through 29 different medical cases, which generated over 16,000 responses. This was a massive head-to-head showdown.
This right here, this slide explains everything. If you just look at a simple accuracy score, which is what you see on the right, all the models look pretty good. They're all scoring between 80 and 90%. They look basically the same. But the Prime LLM score, visualized on the left, tells the real story. You can immediately see that weird lopsided shape. It shows the AI is great at some things and absolutely terrible at others.
And hey, you don't have to take my word for it. The journal itself summarized the key finding. It says right there, differential diagnosis consistently showed the weakest performance, while final diagnosis had stronger performances. Let me translate. The AIs are bad at the very beginning of the process, but pretty good at the very end. And that is a gigantic red flag.
This brings us to what is, without a doubt, the single most important idea from this whole study. Let's really break down what it means to be a good guesser, but a bad detective.
So get this, more than 80%. That was the failure rate for AIs on step 1, creating that initial list of suspects, the differential diagnosis. Over 80% of the time, every single model tested got it wrong. They just couldn't come up with the right list of possibilities.
But then, look at this. The failure rate for naming the final culprit, the final diagnosis, that was less than 40%. So wait a second, how can they be so awful at the first step, but so good at the last one? It feels like a paradox.
And this is where that whole detective thing really clicks into place. A good detective, a human doctor, keeps an open mind. They carefully build a case and make sure they don't miss any clues. But what this study shows is that the AI acts more like a good guesser. It seems to just jump to the most likely conclusion without doing the hard work of ruling other things out. In medicine, that is so incredibly dangerous, because that one rare disease it missed at the beginning, that could be the one you actually have.
The study's authors just put it perfectly. They said the real risk isn't just that the AIs are sometimes wrong, it's that their whole way of thinking is fragile. It's brittle, right at the moment when uncertainty and nuance are the most important. The moments where human expertise really shines.
So, after all of that, what's the final verdict from this huge study? What does this actually mean for you and for the future of AI in the doctor's office?
Now you might be thinking, okay, but these models get better all the time, right? And they do. This chart shows that newer models over on the right generally do score better than the older ones on the left, but look closer. The study found that this fundamental flaw, being really bad at that first step, the differential diagnosis, is still there in all of them, new and old. Just making the AI bigger isn't fixing this core problem.
And so, we get to the final, unmistakable conclusion, straight from the researchers themselves. They state that, because of these ongoing failures in early reasoning, these AIs cannot yet be trusted in frontline decision-making. So, based on the absolute best science we have today, the answer to our original question is a pretty clear and loud no.
Look, this study isn't saying that AI has no future in medicine. Of course it does. But it forces us to ask a much better, much smarter question. The question isn't if an AI can replace your doctor. The real question is, how do we build an AI, and what kind of rules and safeguards do we need to invent to make it a partner we can genuinely trust with our health? Now that is the real challenge ahead.